All right. Can everybody hear me? Yeah? Cool. Thanks, guys, for attending. I'm hoping you guys are having a great build. My name's Karan, and I'm a program manager at Azure Compute. And today I'm going to be talking about the new VM sizes that Scott announced a couple of months ago. And those new VM sizes are GPU enabled, and they're going to be available later this year. So I'm going to talk about where those GPUs are being used, why they're so important for us. Talk a little bit about architecture and technology, how we're bringing up these VMs into Azure, and then show off some few demos as well. So when we set out to build these GPU VMs, we really wanted to make sure that our customers are able to run the high-fidelity apps, make sure that they're able to run simulations that are hardware accelerated. And for that to happen, we really needed GPUs in the cloud. Additionally, we wanted to make sure that all this experience is crisp, smooth, low latency, and very high performant. And we didn't want to do a single GPU that does everything. We wanted to do a specific GPU for visualization and a specific GPU for compute as well. So we're not doing essentially a Swiss Army knife offering. We are going to have separate GPUs for separate purposes. Additionally, we talk about HPC in the cloud, and GPUs are really going to help us close that loop. So imagine running some simulation in a VM, and then you don't have to deal with the data movement. You can just visualize that data in a visualization GPU VM. And additionally, we're working super closely with NVIDIA to deliver these GPUs to make sure that these GPUs work really well for the really high-end scenarios that we're aiming for. So depending on the industries that we're aiming at, just to give you guys a few examples, traders can use the GPUs to do trade calculations in seconds on the trade floor. A lot of CUDA applications can be run to do risk analysis, time series analysis, and so on. Manufacturing is a pretty important one. So if you're designing parts, designing materials, and dynamically manipulating them, so things like glass, metal, plastic, that all utilizes GPU. Additionally, automotive engineering and design, designing the latest concept cars, stress testing materials, crash simulation tests, those are all done on GPUs and can utilize these VMs. Media is pretty obvious, so streaming high-fidelity video games, you should just be able to spin up a VM and run some video and then spin it back down. Additionally, we'll allow service providers to essentially build gaming on-demand kind of services as well. Additionally, you can run encoding, transcoding jobs on these VMs. Tools such as FFmpeg now support GPU-based transcoding as well, which is really important. Rendering is similar to media, but essentially rendering meaning dynamic and offline rendering on the compute stack. So if you're, any brand new movies that you see today, all the visual effects rely upon ray trace rendering that are built upon GPUs. And those things can be run in the cloud today. Designing the latest architecture buildings in AutoCAD, for example, and then simulations for things such as water, oceans, grass, hair, all can be done using GPUs. So talking a little bit about technology, what's so special about these GPUs? These VMs, what we're using is called DDA. It stands for Discrete Device Assignment, and it's part of our Server 2016's hypervisor, Hyper-V, and its capability to allow us to essentially pass through the GPU from our host OS directly to the guest. And the guest can be anything, Linux, Windows, any distros of Linux. And then essentially what this allows us to do is give you the entire GPU for your use. And this results in really, really good performance. So we're aiming for up to 90 to 95% on DDA, meaning that you'll be able to run really, really high fidelity apps. Talking a little bit about architecture and what it looks like from an Azure standpoint. You have the lowest level hardware, the servers that are sitting in the Azure data center. We have the M60 and the K80 GPU for visualization and compute. You have the host OS, in this case will be Server 2016, and we will be using DDA, as I mentioned earlier, as part of Server 16 to expose these GPUs to whatever OS that you want. So you can bring your images, your custom images with your apps, you can bring your marketplace images, you can use data and services on top of Azure. So for example, you can use potentially machine learning down the line on GPU as well. So visualization VM, that's our M60 card, NVIDIA's M60 card. The important thing to note here in these VMs is that you'll be able to get either a single GPU, 2 GPUs, or 4 GPUs per VM. So you'll be able to utilize a whole wide array of different VM sizes. So to demonstrate the visualization capability, I'm going to bring along Randy Groves, who's the CTO at Teradici, to showcase this technology.
Thanks, Karan. Thank you all for joining. For those of you who don't know Teradici, we were founded 12 years ago, and our mission was to deliver an uncompromised user experience across any network, regardless of how graphically intense that application is. And so our piece over IP protocol was designed from day one to flawlessly deliver graphically intense applications from the cloud, even before that was a buzzword in the industry. Now, video codecs are designed and optimized for passive streaming of camera captured content, whereas the piece over IP codecs are designed for highly interactive, graphically intense, delivering the highest quality image, text, and 3D graphics, including the capability to build to a completely lossless image in a very efficient manner for those applications that need perfect color correction and image correctness. Now, we launched our product 9 years ago, and it rapidly became the standard for remoting workstation applications and attracted marquee customers in media and entertainment like Industrial Light and Magic, in automotive with people like McLaren and BMW. We're on the trading floors in Wall Street and all the major hospitals in imaging for medical. And in all the 3-letter agencies for highly secure defense and intelligence applications. Now, that solution that we came out with originally required custom silicon in both the workstation and the client. And so we ported that technology into software that enables a much broader range of applications, including virtual desktops, desktop and application as a service, and allows you to access them from a diverse set of client devices, so including Android, Chrome, iOS, Linux, Mac, and of course Windows. But our silicon clients continue to remain very popular, not only because they're the highest performing clients, but they're also ultra secure and dead simple to manage because they have no application or operating system on them, and they're just silicon. And so we refer to them as piece over IP zero clients. And they are very popular. There are over 7 million piece over IP seats out in the marketplace, and almost 3 million of them have a piece over IP zero client attached to them. Now, we took this software solution and we've packaged it in our Teradici pervasive computing platform, which will allow any developer to remote any application from the cloud. And what we're demonstrating here is our Teradici Workstation Access software, which is a pre-packaged version of the platform that you can download from our website and load it on any Windows 7 or higher PC or workstation, or in a Windows VM that has a GPU in it, like this NV6 instance that we're using here. And if you look, you can see this is running on the M60. It's stressing it pretty heavily, doing 3D rendering of this Unigine game, and it's being delivered very smoothly from the server to Karan's laptop here, and given he's got a very high resolution laptop here, it looks even better up here than what you guys are seeing. It's pretty exciting. So using Azure GPU instances to deliver applications provides a variety of benefits. In a lot of cases, these applications have very large data sets or content files that go with them, and oftentimes they're the most valuable piece of intellectual property in the company. And so by being able to move those large files and co-locate them in the cloud with the application that's using them, and then just deliver the pixels to the users is much more efficient and much more secure than shipping these large files to each of the individual client devices. So let's go to another example here. Let me see. Pull this up. So we'll go to video editing as a perfect example of this. Obviously, for video, the files can be massive. You can end up with files that are multi-terabytes in size. And of course, they're obviously very valuable. You don't want them to leak out onto the internet. You also have the complexity that there's a lot of people collaborating on these videos. And of course, there's lots of people reviewing them, and they're typically not all in the same location. So being able to have these large video files co-located with your video editors is really important. So this is an example of Adobe Premiere, one of the very popular video editing solutions out there. And while the Unigen application that we were showing you uses the GPU to do 3D acceleration, this particular application uses the compute part of the GPU, the CUDA part, to actually do all of these various visual effects that are accelerated over here in the lower left-hand corner. So you can see I've got this video loaded up in here. I can scroll through and very easily, find out where I want to go edit and find what I'm looking at, and all the text and graphics is really crisp and pristine. I can review it smoothly, and let's say my VP of marketing says, "Oh, wait a minute, we need to emphasize the security of this solution. Could you emphasize, put some emphasis on this lock?" So hopefully I'll be able to use my video editing skills. There we go, to make that lock red, and then I can play it back for her, and she can say, yeah, that's what I was looking for. So you can see this provides a lot of flexibility and capability for video editing. Let me talk quickly about one other example. Let's talk about computer-aided design. Let's say I'm an architect, and I've designed a home using AutoCAD, and I need to go show that design off and review it with my client. In the past, I would have had to download that large CAD file onto some workstation class laptop to take to the client. But if I put it up in the cloud, all I need to do is grab my Surface Pro and take it there. When they call me on the weekend to make a change, I don't have to go into the office. I can do it from home. And if you're someone who has a lot of third-party vendors that are working jointly with you on a complex design, you can give them access to the design remotely without actually having to send them the large, valuable design files that you have. And so it's an ideal solution for this as well. So that's just a couple of examples of what you can do with these Azure instances in the cloud. It's the Teradici Workstation Access software, allows you to have a very highly interactive, color-accurate, best image quality for text and 3D graphics solution that's out there. It's available now, and of course will therefore be available as soon as these Azure instances are available. And since it seems to be a theme here, by the time those are out, the Linux VM version of this will be available as well to use on your Azure instances. So anyway, if you have questions afterwards, I'll be up here. So Karen?
Thanks, Randy.
Thanks.
So I'm going to actually show off another demo. And this is Altair's Inspire, which is used by a lot of designers and architects to design little parts for tables, brackets for TVs, and then you can put stress tests on them to figure out what the right and appropriate model to use is at the end of the day. So I'm going to kick off. RDP right here. Oop. So here we have the same VM. So what I'm going to show off here is, as I mentioned, Altairs and Fire. So this application is actually a manufacturing-based application, which is used by designers, architects, to structurally test parts and components. So if I open up a file here, you can see that part here, and you can see the kind of latency that you'll be able to work with when these Azure GPUs come online. So I can look at that model, I can scroll in, scroll down. I can run simulation here as well using CUDA. Additionally, I can actually also optimize here, depending on different types of structural. Then I can look at different cases here as well, depending on what kind of materials, what kind of stress I want to put on it, and then that will produce the actual end result in the part. Another application that I want to show off is LS Pre-Post. It's used extensively today in automotive industry to do crash simulation testing. So if I open up a plot here, and so this is showing essentially two cars. And so I can scroll around here, and then I can actually also run an animation here that will utilize the GPU. So you can see the animation there. Additionally, you can see that the GPU utilization is going up. So it's actually using GPU to accelerate the visual there. And so you can imagine giving your artists, your designers, access to this GPU, and essentially giving them remote access through either RDP or either Teradici's client as well. So as I mentioned, this VM was running an M60 VM, and as part of the M60 VM, we'll be supporting all the Quadro driver support. So that means that if you have applications that you want to literally lift and shift, you'll be able to do that easily as well. So all the driver support is there from a grid standpoint. So to get onto the compute VMs, we have essentially a couple of flavors of the compute as well. So the K80 is a choice of card from a compute standpoint. And again, just like the visualization VMs, you'll be able to get a single GPU, 2 GPUs, or 4 GPUs per VM. We have an additional VM at the end, which has got a difference from a latency standpoint. So you'll be able to get low latency connection between the two VMs. So we'll have RDMA access. So if you're running simulations, deep learning toolkits, they'll be able to utilize the RDMA capability as well. And so I'm going to show off quickly kind of performance from a standpoint of why would you use a GPU versus a CPU. And I'm going to do that by using CNTK, which is Microsoft Research's open source, production-ready deep learning toolkit. So log in here. All right, so these are command lines, so it's not as visual as the visualization VMs, but to give you an idea of what we're doing here. So what you're seeing here on the left side is a tool that actually gives you utilization of all the GPUs that we're running. So on the left side, you can see there's 4 Tesla K80s. On the left side, on the right side, what I'm running is a speech algorithm training. So this is actually the speech training that our internal teams use as well on top of CNTK. And so what you'll be able to see, the number that you want to actually look at is the samples per second that's being calculated on this GPU. So once this gets going, you'll be able to see that this is actually the one running on CPU. So we'll see what kind of samples you get. So actually at the bottom here, you're able to see samples per second here, about 1378. Can everybody see that? Yeah? And then you can see 2,000, close to 3,000 there. And then if I cancel that, and then I run it on a GPU instead, say 2 GPUs, then you'll see on the left side, you'll start to get some activity on those GPUs. So you'll start to see those GPUs being utilized any second now. So again, on the right side, you want to look for the samples per second. There we go. So one of those GPUs you can see is 99%. Another one is 91%. And so you can see that it's about at 18,000 samples per second. So this is showing kind of that difference between running simulation or running speech training on a CPU versus 2 GPUs here. I could similarly run this on 4 GPUs and see very close to linear performance upgrade. And actually, just to prove it out, here we have the 4K80. So this is essentially the third VM that I showed off. And so this will have the 4K80s, and you'll be able to essentially scale out your compute. So as I kind of mentioned, the difference between CPU, GPU, and then running your simulations, you're running your deep learning, neural net stuff on these GPUs. You see that the CPU is obviously a lot slower, and then it's literally almost 3.5 to 4x on 4 GPUs. And then obviously, this is a single VM, and when these VMs become available in Azure, you'll be able to scale out even multiple VMs as well. So Microsoft CNTK is open source. You can download it today from GitHub. You can run the same benchmark that I'm running today, and you can run it on CPU. And then when these GPUs come up, then you'll be able to run them on GPUs as well. And it is multi-GPU. It will utilize the RDMA capability that I talked about, so the low latency connection between the 2 VMs. And so CNTK will be able to automatically take advantage of that when it becomes available. So just a last slide. These GPUs will support everything. These VM sizes will support OpenGL, DirectX from a visualization standpoint, OpenCL and CUDA from a compute standpoint. We're aiming to support as many existing libraries and tools that we can, so you'll just be able to literally lift and shift directly onto these VMs. And then, as we release these GPUs into Azure infrastructure, a lot of services will start to utilize them as well. So you'll start to see things like Bing using GPUs. You'll start to see Hadoop. You'll start to see Azure Machine Learning. You'll start to see CNTK being more utilized on GPUs. So we'll be able to fulfill both compute, visualization, and then kind of complete the circle on HPC. So you can run some simulation on K80, and then you'll be able to visualize it on the M60. So everything stays in the cloud. There's no data movement on-prem, off-prem. You can just have your entire stack on the cloud itself. So both Randy and I are available just right after the session, or if anybody has questions, I think we have a couple of minutes. Yeah. Right. So from a specific service point of view, Azure first-party services, you'll see things like machine learning adopt GPU pretty soon. You'll see some other unannounced services as well. But what we're really going to aim at is potentially marketplace. So a lot of different vendors, and for example, Teradici will have VM images that essentially will need to utilize the N-series GPU. So you essentially be able to go to VM, deploy a VM or deploy a cluster of VMs that have pre-installed software or pre-installed tools or libraries, and then there'll be no setup, there'll be no licensing. You'll just basically get it as part of a single click.
How do you deal with Cleveland, Ohio, as far as latency?
Yes. So we're hoping to deploy these servers in as many places as possible. It's obviously, it's going to come down to if you have dial-up, it's not going to be the best experience. But if you have a decent connection, we're hoping that you'll get pretty decent performance on a visualization standpoint. Compute, once you're into the VM, you're running a simulation locally onto the server. But we're hoping that Azure has got a lot more servers and a lot more geographic locations than any of the other cloud providers like AWS or Google. So we're hoping we'll be able to put these VMs everywhere at the end of the day. Yeah. Anybody else? No? Well, thank you. And please grab me or Randy after the session. We'd be happy to answer any questions. All right. Thank you.